How Artificial Intelligence, AI, works. A simple guide. Artificial intelligence, AI, powers many of the technologies we interact with daily, from virtual assistants like me to self-driving cars and personalized recommendations. But how does AI actually work? At its core, AI uses computers and algorithms to mimic human-like intelligence, such as learning, reasoning, problem-solving, perception, and language understanding. Here's a clear and concise breakdown of the process, blending technical insights with relatable analogies for a broad audience. Data, the fuel of AI. AI systems thrive on data, the raw material that enables them to learn and make decisions. This data can take many forms: text, books, articles, websites, or social media posts, images, photos, drawings, or medical scans, audio, speech, music, or ambient sounds, video, motion footage, or live streams, sensor data, information from devices like GPS, thermometers, or autonomous vehicle sensors. The quality and quantity of data are critical. Think of data as ingredients in a recipe. The better the ingredients, the tastier the dish. For example, to train an AI to recognize cats in photos, you'd feed it thousands of labeled images of cats and non-cats. The more diverse and high quality the data, the better the AI can identify patterns and generalize to new situations. At the heart of AI are algorithms, sets of rules or instructions that process data, and models, the systems built from these algorithms to make predictions or decisions. These models are like the brain of AI, enabling it to learn and act without being explicitly programmed for every task. Here are the key types of AI approaches. Machine learning, ML, a subset of AI where models learn patterns from data and improve over time. For instance, an ML model might analyze customer purchase histories to predict future buying behavior. Deep learning, a specialized form of ML that uses artificial neural networks, inspired loosely by the human brain. These networks have multiple layers that process complex patterns, making them ideal for tasks like image recognition or speech processing. Natural language processing, NLP, a field of AI focused on understanding and generating human language, powering tools like chatbots, translation apps, and voice assistants like me. Computer vision enables AI to interpret visual data, such as identifying objects in photos or detecting faces in security footage. Imagine teaching a child to identify fruit. You show them apples, bananas, and oranges, data, explain the differences, training, and over time, they learn to recognize new fruits, model in action. AI models work similarly, but with mathematical precision and vast data sets. Training is where the magic happens. During this phase, an AI model is fed data to learn patterns and adjust its internal parameters. Here's how it works. Supervised learning. The model is trained on labeled data. For example, to teach an AI to recognize cats, you provide thousands of images labeled cat or not cat. The model adjusts its parameters to minimize errors in identifying cats. Unsupervised learning. The model finds patterns in unlabeled data, like grouping similar customer behaviors for targeted marketing. Reinforcement learning. The model learns through trial and error, optimizing for a reward. Think of an AI learning to play chess by experimenting with moves to maximize wins. During training, the model uses techniques like backpropagation in neural networks to fine-tune its parameters, reducing errors over time. This process requires significant computational power, often running on specialized hardware like GPUs or TPUs. It's like a student studying for an exam. Repetitive practice leads to mastery. Once trained, the AI model enters the inference phase, where it applies its learned patterns to new, unseen data. This is where AI shines in real-world applications. Answering questions. Chatbots like me generate human-like responses based on patterns in text data. Recommending products. Streaming platforms like Netflix suggest shows based on your viewing history. Driving cars. Autonomous vehicles use sensor and image data to navigate roads safely. Detecting fraud. Banking systems flag suspicious transactions by comparing them to learned patterns. Translating languages. AI converts text or speech from one language to another in real time. Inference is like the child from our fruit analogy, confidently identifying a pair they've never seen before based on their prior learning. AI doesn't stop learning after deployment. Through feedback loops, models can improve over time by incorporating user feedback, e.g., correcting a chatbot's response, analyzing new data, e.g., updated customer preferences, undergoing retraining or fine-tuning to enhance accuracy. This iterative process ensures AI systems stay relevant and effective. It's like a chef tweaking a recipe based on customer reviews to make it even better. Data collection. You show the child pictures of fruits. Training. You label each fruit as an apple, banana, or orange to help them learn.
It's a mango!
Feedback. If they misidentify a fruit, you correct them and they improve. AI's ability to process vast amounts of data and learn from it has revolutionized industries. From healthcare, diagnosing diseases, to entertainment, generating music or art. Behind the scenes, it's all about data, algorithms, training, and iteration. While the technical details, like neural network architectures or optimization techniques, can get complex, the core idea is simple. AI learns from examples to make smart decisions, much like we do, but at a scale and speed we can't match.